You know, everyone's talking about machine learning, but let's get real for a second. Beyond all the hype, how do you actually know if it's the right tool for your project? Because if you get it wrong, you're looking at a whole lot of wasted time and money. But if you get it right, well, you can build something truly game-changing. So in this explainer, we're going to build a practical design checklist inspired by the work of ML expert Chip Huyen to help you make that crucial decision.
All right, so here's what we're going to cover. We're going to start by busting some myths and redefining what an ML project really is. Then we'll give you a simple litmus test you can use for your own ideas. We're also going to talk about the big red flags, when to just say no and walk away. And we'll wrap it all up with the single most important mindset you need to succeed.
Okay, first up, let's tackle the single biggest misconception about machine learning. Honestly, this is the one that can doom a project right from the very start. And this quote it nails it. When we hear machine learning, our brains immediately jump to the algorithms, right? The fancy neural networks, the complex decision trees, the secret sauce that does all the magic. And because of that, we get this mental model that looks kind of like this, where the ML algorithm is the star of the show. We obsess over which model to use, how to tune it, what our accuracy score is. But focusing only on this one little box, it's dangerously misleading. Because here's the thing, that fancy algorithm, it's just one small piece of a much, much bigger puzzle. Focusing only on the model, well, it's like trying to understand a car by only looking at the engine. Yeah, the engine is vital, but it's completely useless without the chassis, the wheels, the steering wheel. You get the idea. This is the reality. A successful ML project isn't an algorithm, it's a complete system. You've got the user interface, the data pipelines, the cloud infrastructure, the hardware it all runs on. All these pieces have to work together in perfect harmony. Your success depends on designing the whole system, not just obsessing over one small tiny part of it. Okay, so we get it. We're building a system. But how do we know if that system should even use machine learning at all? For that, we need a simple litmus test. And look, answering this question correctly is going to save you so much time, so much money, and a ton of headaches down the road. Luckily, there's a really clear framework we can follow. We're going to use this definition as our guide, because really, it's not just some textbook definition, it's a checklist. And if your project can't take these boxes, you're probably reaching for the wrong tool. Let's break that down. So first, your system has to learn from data. It can't just follow a bunch of hard-coded rules. Second, the patterns it's learning have to be complex. Third, its main job is to make predictions. Fourth, and this is a big one, those predictions have to work on new, unseen data. And finally, to really justify all the effort, it needs to be able to operate at scale. So let's zoom in on that complex patterns point for a second. Think about it. If your task is just mapping a zip code to a state, like you see on the left, well, that's a simple pattern. A basic lookup table is all you need. No ML required. But predicting an Airbnb's price based on its location, size, amenities, all the recent reviews, that pattern, as you can see on the right, is way too complex to just write down in a set of rules. That is a job for machine learning. Now, this next point is a huge gut check for any project. Your model learns patterns from the data you train it on. So if the real-world data it sees later follows completely different patterns, your model's going to fail, plain and simple. The data you train on has to be representative of the data you'll see out in the wild. And I love this quote because it's a perfect and kind of hilarious way to remember this point. I mean, the app world of 2008, where Koi Pond was the top app, that's a completely different universe from today's app store. Training a model on that old data to predict what's going to be a hit today would be totally pointless. So the question you have to ask yourself is, will the patterns in my training data still hold true tomorrow? So we've talked about when to say yes. But it's just as important, maybe even more important, to know when to say no. So let's look at the big red flags that should make you hit the brakes. These right here are 4 hard stops. First, if a simple, non-ML solution works, for goodness sake, use it. Don't overcomplicate things. Second, if a single mistake could have catastrophic consequences, like in medical diagnostics, you have to be incredibly careful. Third, if the cost just outweighs the benefit, you gotta walk away. And finally, if it's unethical, well, the answer is always no, period. And that cost-effectiveness point is so crucial. The model itself is really just the tip of the iceberg. What you don't see below the surface are the huge hidden costs. Collecting and labeling data, paying for all that cloud computing, and hiring the specialized talent you need to build and maintain these systems. The return on that investment has to be massive to justify all of this. All right, so after all of that, what's the one big idea you should walk away with? What's the core mindset that really separates the successful ML projects from all the ones that fail? It really all boils down to this. This right here is the entire message. The key is to shift your focus. Stop obsessing over the algorithm. Start thinking like an engineer and design a robust, reliable, and valuable system that solves a real problem. The algorithm, it's just one tool in your toolbox. So I'll leave you with this final thought. The next time you have a great idea, don't start by asking, what algorithm should I use? Instead, ask, what is the simplest, most reliable system I can design to solve this problem? Because that shift in focus, it makes all the difference. So what system will you design?